Hello, welcome back. Today we're going to continue our discussion on integration. Now, yesterday we said we took the antiderivative e to the x dx and we got back that exponential function e to the x plus that c. Today we're going to be taking a look at what happens if we have a base that is not e. And this is pretty easy to do. It's just going to be a rule. When we took the derivative earlier this year of a to the x, for example, of a to the x, we said we got a to the x times the natural log of a times u prime. Remember, u is just the chain rule right there. So, and for our chain rule, we're looking at our exponent, that x, the dirt x. So let's take a look at one real quick. So we want to find the following derivative. So take the derivative y equals 3 to the x. My rule says we're going to get the function back right here. So we would get 3 to the x times the natural log of the base. Now there is a chain rule. There's always a chain rule. But in this case, the derivative of x is just 1. So there's my answer. If we take a look at number 2, same thing. We're going to take the derivative of 5 to the sine of x. So we're going to get 5 to the sine of x back. Multiply that by the natural log of the base. That's my rule, the natural log of the base right there. Multiply that by the derivative of the sine of x. That's our chain rule. And the derivative sine is just cosine of x. These I always think were the longest derivatives. They're not very nice. To take the antiderivative of our exponential function, remember, we're thinking inverse of the derivative. And this is, thinking of that way really kind of helps me. You notice in the derivative, when we took the derivative of a to the x, we took a to the x times the natural log of a. Taking the antiderivative of a to the x, our rule is very similar. We're going to get that a to the x back. But since it's the inverse, instead of multiplying by the natural log of the base, we divide by the natural log of the base. And that's our rule right here. Now, there will be a u substitution. There is always a u substitution. Now remember, u substitution is chain rule for derivatives. So once we know that, the rest is not so hard for us to do here. So let's take a look at example number 1 down here. We want to take the antiderivative of 2 times 5 to the 2x. Looking at our exponent there, there is my inside function, just like we did yesterday for e to the x. So that's going to be my u. So we're going to let u be 2x. Our du would be 2 dx, giving us dx is du over 2. Rewriting our integral, we get 2 times 5 to the u du over 2. 2's cancel, and the antiderivative of 5 to the u, that's our rule today, is just 5 to the u divided by the natural log of the base, 5 plus c1. Don't do anything else. There's no chain rule. This part right here, that is the chain rule. We just call it u substitution for antiderivatives. So all I have to do now is replace u. So we would get 5, u was 2x, over the natural log of 5, plus your constant of integration. And there's our answer. Please don't do anything else to it. Don't. Sometimes people think, oh, I got to multiply by 2. I got to do the chain rule. We don't have to because the chain rule was taken care of in our u substitution. So go ahead and try number 2. You can pause the video. I'm going to go and do this one. This is our u sub. So we're going to let u equal dos equis. Stay nerdy, my friends. Our du is 2 dx, and we get dx is du over 2. Again, this is my chain rule, or in this case, u substitution for antiderivatives. So when I rewrite our integral, we're going to get 3 to the u du over 2 in this case. Now I'm going to bring that 1/2 to the forefront, and that's going to give me 3 to the u du. So I get 1/2 3 to the u divided by the natural log of the base. That's my antiderivative. I'm just taking the antiderivative of 3 to the u, plus your constant of integration, and your last step is to just replace u. So we get 3 to the 2x over natural log of 3 plus c1. And there is our antiderivative. Now notice, my work is neat and easy to follow, and that's what we want. That's what the AP wants to see. Okay, so make sure your work is always going to be neat and easy to follow. All right, so let's go and take a look at one more example, and then we'll take a little break for another video, okay? All right, so let's take a look at number 3 here. Same type of problem. It's 5 to the x. Now, I know I'm going to use my rule here, a to the x, because if you notice, my variable is the exponent. So this is not going to follow my normal power rule, because my variable is an exponent. Power rule says this: if it was x to the a, that's power rule, because a is just a number. It's just a, oops, that looks terrible. What happened there? It's just a number for us. So that's our power rule. But if the variable is an exponent, this is our exponential rule. So this is always u. U is always going to be the exponent. Very easy to do. So we get u is negative 5x, du is negative 5 dx, giving us dx is du over negative 5. Rewriting your integral, we get 5 to the u times du over negative 5, du, rewriting it. I don't like this 1/5 out here. I'm just going to bring it to the forefront. And it's a negative 1/5, 5 to the u, du. Please don't cancel those 5s. They do not cancel. You can do something fancy with them, but we're not. Just leave it alone. So we're going to get negative 1/5. Whoop, this is what we're looking 1. And I'll show you what I mean in just a second. So this becomes 5 to the u over natural log of 5 plus c1. Replace the u, we get negative 1/5, 5 to the negative 5x plus c1. There's my answer. Now, I can do something fancy if I felt like it. Okay? Do not do this. I am a trained professional, okay? You can get hurt. These are the same base. Well, we know from Algebra 1, if I have the same bases, n, I can subtract my exponents. So I could also write this as negative 5 to the negative, I forgot over my natural log of 5. Don't tell me I did that. I get 5 to the negative 5x minus 1, because that's just 5 to the 1. I can subtract the power over natural log of 5 plus c1. I could write it this way, but do me a favor, don't. It is correct, but it's just a lot more work, okay? Because I have my same basis. I just use my Algebra 1 property there. All right, hope you guys enjoyed the video here, and I will see you in the next video. Join us for the next one. We'll take a look at a few more examples. See you then.